All right, Chapter 11 review. Last test of the year. It's time to get after it. All right, number one, solve for x. So we're talking about arc measure here. Big thing to know is that circles are 360 degrees. Since I already have two of the arcs, I add those up. I have 125. So when I actually 225, and when I subtract that, I'm left with 135 degrees. So the missing arc, which they say is 16x minus 9, is really equal to 135. And I just go ahead and do my algebra. 16x, add 9 to both sides, that's 144. And x goes in there 9 times, I believe. So x is 9. Number 2, we got two tangents. So back in chapter 1, there was a theorem that said if you have two tangent lines sharing the same endpoint, they have to be congruent or equal. So I just set these two equations equal to each other and do a little algebra. Minus the 7x minus the 1, and you get x equals 4. And if it's a test, you probably want to plug it back in and plug 4 in and make sure that you do get the same number so you didn't screw something up. Shout out to Bryce Sykes back there, keeping it real. Number 3, find the segment length indicated. So the question mark is right here, so I'm going to call that x. We do have a theorem that says if a radius runs into a tangent line, at that point of tangency it's 90 degrees, which should open up the door for the Pythagorean Theorem. It looks like I don't have the length of the hypotenuse, but I actually do, because the radius portion should be the same all the way around. So I'm going to add these two together, and I get 9.7 for that hypotenuse. So now we bust out Pythagorean Theorem. Leg squared plus leg squared equals hypotenuse squared. Now you could get these numbers and write them down, and I would rather just move the 6.5 squared over. So I just leave it like this, and I move it over, and then I go ahead and I square root it, and I just jam all that crap into my calculator. Put parentheses here though, otherwise it gets jacked up and you'll get the wrong answer. When I put this in, I ended up with 7.2. Alright, number 4, find the length of the arc. So this is in section 11.4. Where'd my stuff go? 11.4. So the length of the arc, they actually want to know how long is this piece right here. And so remember, the formula is it's just a portion of the circumference. So you got to know the formula for circumference. It's 2 pi r. So this is going to be a fraction of the circumference. The radius is 14. And then basically you just put how many degrees it is out of the full circle. So 225 out of 360, that's the fraction. And you go ahead and you jam all that in, and I ended up with 55.0 when I rounded to 1 decimal place to the nearest tenth. Number 5 is very similar. Number 5 is a portion, but it's not circumference. Now we're talking about area. A sector is just a piece of the circle or a part of the circle. So they want the big area. I want all of this stuff. So basically all this stuff in blue here. I'm trying to find that Pac-Man looking area right there. So I do 315 out of 360 times pi, radius squared. So biggest mistake is knowing when to use 2 pi r. So remember, circumference 2 pi r, area pi r squared. Kind of look alike, but they definitely get different answers. And for that one, I got an answer of 890.6. Alright, page 1 done. Let's move on to page 2. So here we're going to start getting into arcs and angles and who created who and all that type of good stuff. So first thing I notice, another thing, all circles are 360, but half circles are 180. So I'm looking right here. Since EC is a diameter, this red line, this red arc right there is 180 degrees. Well, I have 102 of it right there. So I can use subtraction, and I can find out that this arc CP here is 78. And why I needed that arc is because to find out how much this angle is, remember this angle made that arc. this angle controls CP because right there is where it gets cut off. And we had a rule that if the vertex is on the circle, then the angle is 1/2 the arc. Alright, angle is half the arc. So we'll just call the angle X. The angle is 1/2 of 78 degrees. So 39 degrees would be the answer to this problem. Similar idea moving over here to number 7. Ultimate goal is figure out what X is. Well, before I can figure out what X is, I need to figure out how many degrees that blue arc is right there. So I'm going to use a couple facts. It looks like I have 130 degrees right here accounted for. It would be nice if I could get this green arc, because then I would know that the red plus the green plus the blue is 360. And I can get the green arc because this 80-degree angle right here, boom, and boom, right there, it created that green arc. So I'm going to use the same fact that I used over here earlier, that the angle is half the arc, except for this time I know the angle. The angle is 1/2, we'll call it X, the arc, and I multiply both sides by 2, and it's 160. Or you just double 80. That's the easier way to do it. So there's 160. So the red plus the green is 130 and 160. We're looking at 290. And the whole circle's got to be 360. So I subtract and I get 70 degrees. So 5x is 70. And then we just got to finish solving that little equation. Divide by 5, divide by 5. What's that? 114. Boom. Alright, sliding on down. Find the measure of the arc or angle indicated. Assume the lines appear to be tangent R. So another situation it looks like here where the this angle, I'll do it in blue, this angle right here is on, so the angle's half the arc. I kind of need to know what this arc is before I can find that angle. So luckily they give me the green, which is 264. So I can find out the red. It's 360 minus 264. That's 96. And then I got to work backwards. So the angle is going to be half of 96. 96 divided by 2 would be 48 degrees. So that angle right there is 48 degrees. Alright, number 9 gets a little more involved. I have the angle that I'm looking for is on the inside of the circle. So here's the angle I'm looking for. Remember, this angle is the same because they're vertical angles. And since my vertex is in the circle, got to use a little bit different theorem. When the vertex is in, it is the angle is 1/2 the sum of the two arcs. So I do arc plus arc, add those together, because if you notice, this arc is controlled by a blue angle, but this arc is also controlled by a blue angle. So, which one is it? You actually use the sum of these guys. So one arc is 55, the other arc is $1.15, and it looks like that's 1/2 of, what's that, 170. So half of 170 is 85 degrees. So that's the answer to this one, 85. Moving on down. New game going on here. Looks like I'm looking for an angle, and this angle is outside the circle. Whoa, a little bit crazy there with my line. So my angle C that I'm looking for, when I look at the vertex, it's outside. So when you're outside, the angle is 1/2 the difference. And you got to do big arc minus little arc, otherwise you'll get a negative, which isn't that big a deal. I'm sure you'd fix it, but might as well do it right the first time. So I'm looking for the angle. The big arc is $1.60. The little arc is 50. So 160 minus 50 is 110. and then half of 110 is 55 degrees. So there's the answer for number 10. So all that stuff right there, that was all in section 11.5. If you're trying to figure out where it is in your notes, those are the three big theorems that you need. You need vertex on, vertex in, vertex out. Make sure you have those three on a cheat sheet if you have trouble reading the board during the test. Alright, moving on down. Now we're getting into the segment measures. So remember the players in this game, you have tangents, you have secants, and you have chords. And they all have special relationships and there's theorems with them. This is in 11.6. So if you're struggling in this section, go back to your notes. Check out 11.6. Let's get after it. So red line is a tangent. Blue line is a secant. And the rule was it's the tangent squared equals, and for the secant, it's the whole piece times the outside portion. So let's translate this into some numbers. The tangent is 45 squared, and the secant, when I add up these pieces, I have 27 and then x, so the whole piece is going to be 27 plus x. The outside portion, which is just this piece out here, is 27. So we're going to be doing a little distributive property here. 45 squared is 4 times 5 is 20, 25. 27 times 27, I'm going to have to check my calculator here in a second for that. I don't know how to do that one. Let's see, 27 times itself was 729. And I'll do a little bit of algebra. I'll go 27x. I'll subtract 729, so that'd be 1300, be 1296, I believe. And divide by 27, divide by 27. I'm going to cheat here and look at my answer. It looks like 48. So x equals 48. So that would be how long this inside portion, just this little chord right here, would be. Alright, number 12. On number 12, we actually have two chords. So we have this purple chord that's made up of two segments, and then we have the blue chord that's made up of two segments. So when you're talking chords, it's piece times piece of one chord equals piece times piece of the other. So I'm going to go ahead and bust these out. So when I look at blue pieces, I have 20 times x equals, and then the purple pieces are 30 times 18. And I'm just going to go ahead and knock these out in one color, save some time. So 20x is 540. Divide both sides by 20, and you get x equals 27. Again, if this was a test, I would probably stick that in and I would multiply them out just to make sure. You know, if it's a multiple choice test, I might not even go through that work. I might check the four answers, just plug them in and multiply. It might be quicker for some of you that your algebra is a little suspect. Moving on down, number 13. 13 looks like two secants. So secant times another secant. So remember, these ones are the whole times the outside of one is the whole times the outside of another. And so let's do this one first. This whole piece is 18, and then the outside portion is 8. On the other side, the whole piece is x plus 9, and the outside portion is 9. And you can put this 9 on either side, distribute how you want, but it all shakes out to be the same. 8 times 18 is 80 and 64, so that's 144. 9x plus 81. Subtract that 81 from both sides. That would be 64. Take away another one, 63. Divide. X is 7. Alright, now we move into the this is the last section. This was 11.7, the circle equations. These should go pretty fast. I don't think they're too rough. So remember that the key with the center is it's opposite. That's what you got to remember. That's the big thing here, is it's opposite from what you would think. So for instance, if it's plus 12, the x-coordinate is actually minus 12. Since this one's negative 9, this is actually a positive 9. And then the way the formula is built is r squared is 49. So if r squared is 49, the radius is the square root of that, which is 7. So these are the two things that you'll have to know on the test, is the center and the radius. So I give the equation, you spit back to me the center and the radius. Go to the next one. Now they give us a picture. We got to come up with our own equation. So the two things I need, just like before, I need the center and I need the radius. So looking at this picture, one thing that I got to be careful on is, so when I look at the x-axis and I look at the y-axis, I can't just count blocks, because it looks like these go by a half, 1 half 1, 1 half 2, and it goes the same way the other way. So you'll notice this is really 1, this is 2, this is 3. So be careful counting blocks. So the center is actually at positive 2 comma 0. The radius, it looks like it's 2, but it really goes from 2 to 3, so the radius is 1. So now when I bust out my equation, the x-coordinate goes here. It's going to be x minus 2, because I'm doing opposite, squared. Since 0 didn't do anything, it didn't move up or down, I can just leave it as y squared. It wouldn't be wrong to put y minus 0 or plus 0, but it's kind of a waste of time. And then down here is the radius squared, so 1 times itself is 1. 16 was a bit of a challenge, just because of this. You're kind of sitting there being like, hey, what's r? You know, the first part's pretty easy. You take these and you do the opposite. So there's the x component. Remember, it's always plus in between there, otherwise you get a hyperbola. The y is opposite, so it's plus 3. So again, I made sure to do my opposites. Here's where I'm kind of in a crunch, and you got to kind of remember that circumference, why do they give me this clue? Well, circumference formula is 2 pi r, but they're telling me that the answer was 8 pi. So I can figure out what r is. You might be able to look at it, but if I cancel pi out on both sides, 2 times what is 8, so the radius is 4. Now, don't just stick 4 in down here, because remember, we gotta square it. So that's where the 16 will come from in the final answer. What else we got? Alright, so now we get into the short answer. These are a little bit trickier. So this will be what it's going to take to get you to like a B or an A. If you do the above stuff, that'll pass you, but this is to see who's who. So, see who the raw dogs are. A chord of 30 is 7 centimeters from the center of a circle. Calculate the area. So ultimately, I need to calculate the area of a circle. So I need to know that that's pi r squared. So we got to find the radius somehow. So let's draw the circle. We have a circle and a chord of 30. So here's my chord, it's 30. It's 7 from the center. Alright, so if here's the center, and I'm going to draw a radius, boom, it's 7 from the blue line to the center point. That's 7. And we had a theorem back in, what was it, 11.3. You know, since this is a distance, it's got to be 90 degrees. Whenever a radius is perpendicular to a chord, it bisects it. So that 30 really got broken down into 15 by 15. Now this is going to allow me to find the radius of the circle, because if I draw my own radius in right here, call it r, I can do a little Pythagorean Theorem move. So 7 squared plus 15 squared equals r squared. That's 49 plus 225 is r squared. This is 274 is r squared. And then finally I'm going to take the square root of both sides. And when I take the square root of both sides, I end up with, oh, I gotta punch this in, I guess. So square root of 274 looks like about 16.55. So now I can find, I did a lot of work to get r, but now I need to plug it into the area of a circle. Pi times 16.555 squared, which is 855.3. Number 2, you are riding an airplane at an altitude of 5.5 miles above the Earth. Furthest point on Earth you can see, remember the diameter is 7920. I'm going to go off the grid on this one because I don't really have enough room there. So let's kind of draw this. So we got our Earth, big old Earth, and you're flying up here in an airplane. And you are exactly, here's the radius, and here's the distance you are above the Earth. That distance up there, maybe I'll put it in a different color. This distance above the Earth is 5.5 miles. And how far are you from the furthest point you can see? Well, the furthest point you can see is actually, and I'll do my best to kind of draw this, is actually, you can see right to about there. And then the Earth starts disappearing, you can't see it anymore. So we're going to use way back from 11.1. You have a tangent line to a radius, which is a 90. So key thing to know was that's a tangent line. Then they tell me what the radius of the Earth is. They say that the diameter of the Earth is 7920, which means the radius is half of that. Oh, what's half of that? Let's bust this out. 7920 chopped in half is 3960. So my radius is 3960. And this blue piece over here is also 3960 because that's a radius. So it looks like I can figure out the hypotenuse here. It's 3965.5 when I add the red and the blue. And I should be able to bust out the tangent line. I'm going to call the tangent line X. I could set up a little Pythagorean Theorem issue going. So let's do this. X squared plus 3960 squared equals 3965.5 squared. And again, I'm just going to go ahead and do this all in one big old swoop. And 3965.5 squared. Take away 3960 squared. You could do it your own way. But when I did all that, it looks like X comes out to be 208.8 miles. So if you're up in a hot air balloon 5.5 miles above the, or in an airplane 5.5 miles above the surface, you can actually see a distance of 208 miles to the edge of the Earth. Interesting. All right, number 3, diameter of a circle is 50, parallel to a chord that's 32. What's the distance from the chord to the center? So I'm going to go off grid again. We'll do number 3 here. So I got a circle. Here's the center. My diameter is 50. I have a chord parallel to it that is 32. Now, since the chord is parallel, I have 90-degree angles here. And since the radius hit it at 90 degrees, I can break it up into pieces, 16 and 16, and 25 and 25. And I should be able to use Pythagorean Theorem here. So let's go ahead and let's just connect this line, which is also 25 because it's a radius. All radiuses are equal. So to find the distance between the two chords, Pythagorean Theorem, x squared, 16 squared, 25 squared, x squared plus 256 equals 625. And later, brother. When I do 625 minus 256, I get 369. And then we take the square root of both sides, and I will get 19.2. So 19.2 is the distance between the two chords. So Pythagorean Theorem is used a lot in this lesson. A lot. All right, number 4. All right, last question, number 4. It's got a few different parts to it. So actually, let's see, we did that last one. So I'm going to go off the grid here for this one, for number 4, where I can give myself a little bit more room. Alright, so it says Kraft is riding on a hot air balloon. He estimates the viewing angle of the Earth formed by two tangents at 120. So here's a picture of the Earth, and I'm up here in this hot air balloon, and I can see tangent line, so it's the furthest I can see. It's going to be way over here and way over there. And this picture's not going to be drawn to scale, but we'll kind of do our best with it. And it says that the viewing angle formed is 120 degrees up top there. And then I got to use my fact about radii, that the radius here is 90 and the radius to this tangent is 90. Now what that can do, because I know that all quadrilaterals add up to 360, I'm at 120, 90, 90, so that's 0. I'm at 300 degrees right now. So that leaves 60 degrees for this angle right here. So that's a 60-degree angle, which that's going to help me answer. So part A is that picture right there. That's the pic. Part B says, what is the measure of the arc viewable from the balloon? Well, the measure of that arc is right here, and since this is a central angle, it matches. It's going to be 60. So 60 degrees is that guy. And then it wants to know if the radius of the Earth is 3960, just like it was before. Calculate the distance from the Earth's surface to the balloon. So I'm going to connect this line right here, and basically I'm going to split this kite right in half. And I'm going to focus on this triangle, either side, one or the other, but I'm going to redraw this so it's a little bit easier. But I'm going to draw this triangle right here, because that hypotenuse is going to allow me to figure out my little distance. You know, my little distance up here, we'll just kind of call that x. So let's draw this triangle. I have a right triangle, and when I break it down like that, it looks like, and I'm going to have to maybe draw this so it's a little bit more to scale. But this angle up here is 60, because when I chop this 120 in half, I get 60. And when I chop the 60 in half, this is 30. So this is a special right triangle. And since I know that this side is 3960, and this is what I call, you know, the freak side. This is the middle side. I could use SOHCAHTOA if I wanted to, but I'm going to use the trick that to go to the baby, I'm just going to divide by the square root of 3. That's a trick that we learned before with special right triangles. So I'm going to do 3960 divided by the square root of 3, and that comes out to be 2286.5. 0.3. And now I have a really nice relationship, because if the baby is 2286.3, the big side over here is double that. So I can just take this number and I can times it by 2 to get that one. So when I double that number times by 2, that gives me 4572.6. So 4572.6. So that is the length of this line, 4572.6. So now I can figure out what x is. I take 4572.6. I'm going to subtract this radius portion, minus 3960. And when I do that, I get 621. Looks like right there, 612.6 miles. Holy smokes. So I don't think that's a very realistic word problem. I don't think I'd be 612 miles up in here in a hot air balloon, but nevertheless, that's the answer that came out. Alright, so hopefully you use this video to watch the questions that you miss when you're looking at the solutions, and of course you can always ask me in class, but it's nice to have it where you can go back and rewind it and replay it again. So good luck on the test. See you.